Leon Thevenin was a French telegraph engineer who extended Ohm's law to the analysis of a complex electrical circuit. Thevenin's theorem states that you can simplify and transform any linear circuit into an equivalent circuit that has just one single voltage source and a single series resistor connected to a load resistor. We use Thevenin's theorem to determine the effect of a component on a circuit. We want to simplify the circuit seen in Figure 1 to determine the Thevenin's equivalent circuit. So step 1 to do this is to remove the variable resistance from the circuit as shown in Figure 2. We will input this at the end of all the steps. Once simplified, we need to calculate the Thevenin's equivalent resistance. In order to do this, we need to short out all voltage sources, which can be seen in Figure 3. Following this, we need to calculate the resistance from the perspective of the open terminals. We can see that the 3 ohm and 6 ohm resistors are in parallel to each other. So we use the parallel resistance formula, which is R Thevenin equals 1 over 1 on 3 ohm plus 1 on 6 ohm, which is equal to 2 ohm. Now that we have calculated the Thevenin's equivalent resistance, we can calculate the Thevenin's equivalent voltage. The first step to do that is by reinstating the voltage source, as seen in Figure 4. Now, to calculate the Thevenin's equivalent voltage, we need to calculate it across the terminals A and B. You may have already noticed that it is parallel to the 6 ohm resistor, and that is going to make our life much easier because we can calculate the voltage across the 6 ohm resistor, and that will be our answer. In order to do that, we need to use the voltage divider rule. It is important to note that the total resistance in this case is not the same as the previous total resistance because we are not calculating it from the open terminals, but from the source voltage. We use the formula E Thevenin is equal to 6 ohms over 6 ohms plus 3 ohms times by 9 volts, which is equal to 6 volts. So now that we have found E Thevenin and R Thevenin, we can place this back into the circuit. Figure 1's Thevenin's equivalent circuit is shown in Figure 5. Thevenin's theorem is especially useful in helping engineers estimate input and output impedance of complex circuits.